Hey guys, another video here on area of a triangle, and this is 11F in your textbook. Okay, so a little bit of background first before we get to a formula. So a triangle is half a parallelogram. So we did parallelograms in 11E, and a triangle is half that size. So the area of a parallelogram, just to recap, is base times height. And so it makes sense that if it's a triangle is half that size, that we halve that formula. Okay, so that is the formula to find the area of a triangle. So it can be written in two ways. So the way that I've written it there, to me, makes the most sense when we do our actual working for questions. But you might also see it written as half BH, B for base and H for height as well. Either way is fine, but for me, doing the working that way just allows me to do it easier in my head instead of using a calculator. And of course, there's no calculators in your exam. So important to note. So just some theory. Base is along the bottom of one side and the height is perpendicular to that. Okay, so one side of a triangle is called a base, B. Any side, it doesn't actually matter, so long as you are then pairing it up with a height that is correct. So the perpendicular distance, so that's at 90 degrees. There's some different examples there. From the base to the opposite vertex, so vertex is the corner, is called the height. So whatever vertex is opposite the base, the height from the base to that vertex, so long as it is at 90 degrees, is the one that you're really looking for. A lot of the time it will be labelled on the diagram, but you've just got to make sure that you're selecting the correct measurement and you're not choosing two sides, for example, instead of a base and a height. I hope that makes sense. So the three examples that we've got here, this is a right angled triangle, so the height is actually one side along there, despite what I just said, but the height in this case, because it's at 90 degrees, that counts as the height. The other two examples are different kinds of triangles, and so the height would be 90 degrees up to this vertex here, whatever that distance is, and that's inside the triangle. On this one, because it's not possible to get up to this vertex at 90 degrees, then that's why the height is on the outside there. That's the only place it can be. So we would only use this measurement, not all the way along, but this measurement here as the base length, and then this height here. Made a great big mess of those diagrams, but anyway. Okay, so anyway, let's do some questions, and I think that will make a little bit more sense to you. So I've got two triangles here, we'll do one at a time. This one, the height is inside the triangle, and this one, the height is outside, but we're still going to use the correct measurements. So as always, we're going to write down our formula. So A equals BH, B times H, over 2. Okay, so the one I've got here, base is 12, and height is 7, divided by 2. That's a bit better. Okay, now it's important here just to take this little extra step and tell me what this part is by itself. So that's 84 divided by 2 still. And then of course that gives me 42. And I just check my measurements, they're both the same, centimeters and squared, because it's an area measurement. Okay? Let's do this one as well. A for area equals base times height over 2. And we've got base is 8 times height is 6, and I double check that it's the right unit of measurement, so they're both the same, both in meters in this case. So that's 48 over 2, which equals 24 meters squared once I divide by 2. Okay, well done.